Alright guys, so we are going to start by taking notes on this page, and what you're going to do is we already have some on this page, so we're going to zoom in and we're just going to finish this section of the notes. So we are going to talk about isotopes. And so isotopes are just elements or atoms that are slightly different than the elements or atoms that we normally deal with. And so at the top we're going to write isotopes. And isotopes are atoms of the same element that can have different masses caused by a different number of neutrons. And so in other words, our protons, our number of protons, positive, is the same. Our number of electrons, or negative, is the same. And the only thing that's different is my number of neutrons. And this is what's going to be different. Now, with that being said, the way that this is denoted is by the number that's on the outside. And so if I have carbon 15, this number on the outside, as we went over in our notes, this is my atomic mass. Now, if we look at our element box of carbon, it's got an atomic number of 6 and a mass of 12.01. And the reason this is a decimal here is because it's an average. Not all carbon molecules are 12. Some are 12, some are 15, like we have right here, and some are 13. And the way we get this number here, is by averaging what's present in the environment. And so, carbon still has an atomic number of 6, which means that my protons and electrons are going to equal 6. And then I know that my number of neutrons is equal to my atomic mass minus my number of protons. So my atomic mass is 15 minus my number of protons, 6, means that I have a number of neutrons, 9. Okay, and so all we're looking at are elements that have a different atomic mass because we have extra neutrons. Now, we're just going to make a little note here on the bottom that states my atomic mass is an average of different isotopes of the same element. Alright guys, so what you're going to do is you're going to go to your worksheet and you are going to calculate using this information here and the same thing I did here to calculate your number of protons, electrons, and neutrons in different isotopes that exist on the periodic table. If you have any questions, please shoot me a remind. I'm always here to help. Have a good day.